Welcome to this week's update on the latest breakthroughs and developments in additive manufacturing. From cutting-edge 3D printing innovations to major industry shifts, here's everything you need to know. Kicking things off, Honda has released a rare report showcasing how it is redefining precision manufacturing with in-house metal 3D printing. Leveraging laser powder bed fusion technology, Honda's document details how it is streamlining production to create intricate, lightweight, and high-strength components. This innovation is making waves in high-performance applications, from F1 engine pistons to customized wheelchair handlebars, demonstrating how additive manufacturing is enhancing both automotive engineering and accessibility solutions. Shifting gears to space, the European Space Agency has taken a historic leap in off-world manufacturing by successfully 3D printing metal components aboard the International Space Station. This milestone paves the way for future self-sufficient space missions, where astronauts could produce tools, spare parts, and structural elements on demand. With samples now back on Earth for testing, scientists will assess how microgravity affects the printing process, offering invaluable insights into the future of space-based fabrication. Back on solid ground, AI and additive manufacturing are coming together to revolutionize mining tool repairs. The Fraunhofer ILT-led project is using AI-assisted directed energy deposition (DED) to extend the life of heavy-duty mining tools by applying customized coatings of tungsten carbide and stainless steel. This not only reduces resource waste, but also cuts maintenance costs, making industrial operations smarter and more sustainable. Moving on to industry shakeups, the legal battle between Desktop Metal and Nano Dimension over their failed merger deal is intensifying. A court date has been set for March 2025, with Desktop Metal accusing Nano Dimension of failing to secure regulatory approvals in a timely manner. The situation has been further complicated by Nano's separate acquisition of Markforged, making this a case to watch as it could set a precedent for accountability in major AM industry mergers. In another major business move, Metal Powder Works, MPW, is preparing for its Australian Stock Exchange debut after merging with automated welding firm K-TIG. MPW's direct powder technology delivers an impressive 95% material yield, far exceeding traditional powder atomization methods. This merger strengthens the global additive manufacturing supply chain, particularly in aerospace and defense, by ensuring more sustainable and efficient powder production. Meanwhile, nTop is bolstering its computational design capabilities with the acquisition of cloudfluid. This move enhances real-time simulation and optimization of fluid flow in complex geometries, giving engineers in aerospace, defense, and industrial applications the ability to refine designs faster and more accurately. By integrating cloudfluid's GPU-native computational fluid dynamics solver, nTop is accelerating the development of high-performance AM applications. Switching to military applications, Beehive Industries is revolutionizing drone propulsion with its additively manufactured frenzy engines. These lightweight, high-performance engines enable the rapid deployment of UAV swarms for military operations across land, sea, and air. With the ability to customize thrust, size, and ignition, Beehive's innovation is shaping the future of drone warfare and tactical aerial missions. In the automotive world, Ford's return to Formula One is still a year away, but its partnership with Red Bull is already yielding impressive results. Over 1,000 3D printed parts, including cold plates for batteries and hybrid engine cooling systems, are undergoing extreme testing. This work is expected to not only enhance F1 aerodynamics and efficiency, but also influence mainstream automotive production, improving performance and durability for everyday vehicles. Shifting focus to traceability, digital product passports are transforming additive manufacturing. Integrated with Desktop Metal's binder jetting technology, these digital records track a part's entire life cycle, from raw material sourcing to final recycling. By enhancing quality control, regulatory compliance, and supply chain transparency, this innovation is setting a new benchmark for the industry. Finally, in the realm of advanced materials, Scandium Canada has filed a patent for aluminium scandium alloy powders designed to reduce microcracking in the additive manufacturing process. These high-strength, lightweight alloys hold significant promise for aerospace and automotive applications, with the potential to reshape next-generation AM materials. That's a wrap on this week's biggest stories in additive manufacturing. Stay tuned for more updates and keep innovating.